Hello and welcome to Tea Time, where we take down the patriarchy and talk about particle physics today. So, what's the biggest question in physics? I would say the biggest question is what gives matter mass? And I'll tell you, but kind of. First, to understand mass and what gives matter mass, we have to understand mass versus massless. So, massless particles only travel at the speed of light. That's one of the quirks of being massless. You get to travel at the speed of light, don't travel any slower, but that is also your amartia. But if you have mass, you get to choose what speed you want. You could travel at any speed you want, except the speed of light. You cannot travel at the speed of light, and you cannot travel faster than the speed of light because that has yet to be proven to be possible. So, what is the point of this? Well, today we're talking about particle physics, so let's talk about the Higgs boson. The Higgs boson is a particle that derives from the Higgs field. The Higgs field is what gives matter mass. The way that the particles interact with the Higgs field give it mass. The particle will slow down and interact with the Higgs field so that it kind of gets bigger and it gains mass. But particles such as light photons also can just pass through it, not interacting with it and still being massless and still traveling at the speed of light. And prior to entering, all of the particles are the same. They all travel at the speed of light, but depending on how they interact with this Higgs field, they either gain mass or they don't. So let's talk about the Higgs boson. The Higgs boson is what happens when the Higgs field has a lot of energy in it, and this produces a Higgs boson. The Higgs boson is a particle that surmounts from the Higgs field. So the Higgs field contains so much high energy that it creates this particle, this fleeting particle that we know as the Higgs boson. Also, it's said about 1 in every billion, I'm not sure about the statistics, 1 in every billion collisions create a Higgs boson. And actually, after further research that I have done, I found that the number used in my source actually produced that a Higgs boson is made in every one of a bajillion. So we don't even know. It's just extremely rare that these are made. And it's so hard to forcibly make them as seen with the particle accelerator. And this Higgs boson fits the standard model. So when you're trying to put mass as an input into the standard model, it doesn't work. When you're trying to configure other things in order to produce mass as in an equation, you can do that. And this equation must have the Higgs boson in it to make the standard model possible. And the standard model was proven possible back in... What is the standard model? The standard model is basically the theory of everything, but it doesn't take into account some things. For instance, it doesn't take into account gravity. The standard model does not even touch gravity. So the standard model is just what fits everything kind of universally. Particle physicists did find the Higgs boson, and this was a big occasion. And now there was only one thing left. What else to do? With the particle accelerator, we were able to put protons circling around each other at high speeds, and when they collide, they form other particles such as the Higgs boson. And the Higgs boson, it is kind of short-lived. So the Higgs boson eventually decays into particles that make us up, and the Higgs field actually likes interacting with itself so much that it actually gives more mass to the Higgs boson, but then the boson decays and becomes particles like us. So you probably have part of a Higgs boson in you, or a decayed Higgs boson in you. But we still have big questions in physics. We don't know what it's made up of, we don't know its properties, we don't know much about the Higgs boson, but we do know that it is there, and that this could elevate standard physics as we know it, and maybe modern physics will not be just general relativity anymore. Thank you. Please comment down below what tea you're drinking. And just to fully round things out, the Higgs boson is still in the works. The Higgs boson is still being discovered. We did find proof of it back in 2012, like I said, but there's still a whole lot we don't know about modern physics.